Hi, today we are going to take a look at this vertical gyro. So we can see the reference of this one. It was manufactured by Ferranti, probably in the 60s or early 70s. Okay, so there is here a small document. And there is a date here, 72. This unit is sealed. We can see on the front 3 Plessey connectors. Okay, so we can see the serial number here, 575/63. So probably 63 is the manufacturing date. Okay, so we can see that effectively this thing is sealed. We can see here the soldering, and you can see this tube here. Okay, so the best thing to do maybe is to cut the wires directly. So this is the outer gimbal for the roll, and we have here the inner gimbal for the pitch. We can see that we have 2 leveling sensors, one here. Okay, so there is a ball of mercury inside. Okay, and there is another one we can see here. So we can see here the first torquer. Oh, this is the torque motor. We can see the windings here. Okay, so this torque motor generates the torque along this axis here. This permits to change the orientation of the outer gimbal here. Okay, so this torquer is connected actually to this leveling switch here. Okay, and the leveling switch of the inner gimbal is connected to the torquer, which permits to generate torque along this axis. And this torquer, it is difficult to see, but it is on that side here. We can see here 2 air wound potentiometers for the pitch. On that side there is another potentiometer for the roll. Okay, so we can see this capacitor. This capacitor is used for the torquer. It is connected to the windings, okay, of this torquer we have seen. There are actually 2 windings on this torquer. This point is the middle point of the windings. Okay, so you can see that we have effectively a connection between this torquer and the leveling switch here. Okay, and we can see also that we should have a synchro here. Okay, so we can see, it is not easy to see, but okay, we can see the windings here. For the roll, we have 2 outputs, one synchro and one potentiometer. But for the pitch, we have 2 potentiometers. Okay, so here we can see 2 relays. Okay, so you can see these 2 relays here. I don't know what is the purpose of these relays. And we can see that we have here 3 transformers, or maybe auto transformers. So here there are 2 wire wound resistors, and there is another capacitor here. It is, I think, used for the second torque motor, which should be Yeah, so we can see the winding here of this torquer. Okay, we can see 3 wires here, red, white, blue. This is probably the connections for the AC motor. Now this is the complete schematic diagram of this Ferranti vertical gyro. Let's start with the leveling circuit. We can see here the pitch leveling sensor. It is connected to the roll torquer, which permits to level the pitch. We can see here on the top the pitch torquer, which is used for the roll leveling. And we have here the roll leveling switch. So we can see that the roll leveling switch is connected to the pitch torquer through these 2 relays here, which are in cascade. When none of these relays is energized, the roll leveling switch is connected to the pitch torquer, so therefore the roll leveling is activated. But you can see that if one or both relays is activated, in that case the roll leveling switch is disconnected from the pitch torquer. Instead of that, the pitch leveling switch is connected to the pitch torquer here. In that case, the roll leveling is not used anymore. Okay, and there will be a change of the roll depending on the pitch leveling. So I think this is used for a kind of test, but I am not totally sure. It is the first time I see something like that. We can see here the roll synchro transmitter and the potentiometer, which is linked to the shaft here, okay, for the roll output. And we can see here the 2 potentiometers for the pitch. During the reverse engineering, unfortunately, I have noticed that this terminal is open actually. So I think that one winding of the gyro motor is open. So therefore, the gyro motor cannot rotate, and the gyro itself, of course, cannot work. Here we can see the 3 wires for the AC motor. Okay, so there is a resistance of 80 ohms here, but we can see that the white wire here is open. Okay. Okay, so I will do a complete teardown of that device. Now this is the roll potentiometer. We can see here the rotor and the stator of the synchro. We can see here the slip ring contacts. We can see here the rotor of the torque motor on the roll axis, which permits to change the pitch. The stator is this thing here, which is actually a short circuit. Okay, the torque motor uses eddy currents flowing through the stator here. We have here the complete gimbals assembly. So this is the torquer of the inner gimbal, the pitch, which permits the leveling of the roll. This is the inner gimbal. Okay, so this is the gyro rotor. Okay, the motor is inside. Now this is the gyro motor. Okay, so this is the stator. And this is the rotor. One winding is cut somewhere inside. Impossible to see, of course.